In this video, I will go over your Pre-Calculus Unit 8 review. So first we're going to literally use a ruler and protractor to draw some vectors. These are all standard position vectors, so from the positive x-axis going clockwise. So our first one is at 50 degrees. So we put our protractor down, and then we're going to go here up 50 degrees. Okay, I'll put a little dot, and then we are measuring this 3 centimeters. Okay, so the 50 degrees was measured here, and this is vector A. B, 115. So 115, we're going, this is going to be past 90. So this is 110, this is 120, so 115 is right in the middle there. And this one is 1.2 centimeters. Okay, next one's at 200 degrees. So that's going to be below the axis, 20 degrees. Okay, so this one's 0.8, so little guy. Okay, so just 0.8, so you go to 8 dashes. That's 20. And then D has a magnitude of 2 and a angle of 320, so you're going all the way around. I think about this as all the way would be 360, so 320 is going to be 40 less than that. And we're drawing this one. Uh, 2 centimeters. Next, we're going to add these vectors, and we're going to do this geometrically. So when adding vectors, you add tip to tail. So I'm going to be adding D and B. It does not matter which is first. So I'm going to go ahead and draw D just like we did above. This is 40, and we're going 2 centimeters. Okay, so that's D. Then I'm going to make a horizontal line where that one ends. And I'm going to construct my next one based on that. So A had an angle of 50. Okay, and it is 3 centimeters in length. Okay, so this is A. My resultant vector is going to be from the start to the end. So this is A plus D, or D plus A. Okay, we want the magnitude and direction of this, so we're going to measure it, and this is about 2 centimeters long. Nope, not that one. That one is 2 centimeters. Sorry, we're measuring the red one. It's about 3.6, 3.7. For the direction, we want the standard position angle. So we're looking at this angle here. So I'm going to use my ruler to extend that out. It's crossing about 20 degrees there. Okay, and there's definitely some wiggle room there. So if you didn't get exactly that, you're good. Okay, the next one we're going to do is C plus B. So first I draw C, just like we did before. we'll draw a horizontal line where that one ended. Okay, and then we'll construct our B there. Okay, so there's my vector B. Our resultant goes from the start of this one to the end of this one. Okay, and then we'll measure it. So the length here is about 1.5. Okay, and then my direction is going to be that direction. It's from the positive x-axis to our vector. So I'm going to extend it with that and measure. Okay, so it's about 140, maybe 145-ish. And again, there's some wiggle room there. Right. A plane flies at a speed of 320 miles per hour on a heading or bearing of 210 degrees. There is a wind blowing out of the southeast towards 335 at a speed of 30 miles an hour. What is the ground speed of the plane and what is the course over ground? Okay, so first we'll draw the vector. So bearings start at due north, so that's 0, that's 90, that's 180, that's 270. Okay, so a bearing of 210 is going to be down here. To get from 210 to 270, the reference angle that we're going to need is 60 degrees. So the 210 was that magnitude of 320, and I'm going to call that P. On this one, I'll put the wind. So wind is 335, so that'll be in that quadrant going all the way around. This angle will be 65 degrees. This is 25. I'll call that W. So then we're going to break these into their components. So I'm going to... So we're going to break them down into their components. So my plane is going to be, so it's a negative, so negative 320 cosine the reference angle, which is 60. And I'm going to use my I and J notation. You can use whatever makes sense for you. Minus 320 sine 60 J. After you type those in the calculator, you get negative 160I and negative 277.128J. For my wind vector, my reference angle is 65, and we have a negative positive. So this will be negative 25 cosine 65I plus 25 sine 65J. Okay, when you type it in the calculator, we get negative 12.679I and 27.189J. Now, to add the two vectors together, okay, we're simply going to add these two values together and add these two values together. So we add them and we get negative 172.679 in our x direction and negative 249 in the y direction. Next, we'll find the magnitude. So we simply just use the Pythagorean theorem. We get a speed of 303.789 miles per hour. So that's how fast the plane is actually going, with the wind slowing it down a little bit. For the direction, theta is going to equal the tangent inverse of the y over the x, ignoring the negatives. Okay, this gives me an angle of 55.36 degrees. Okay, we need to turn that into a bearing. So I'm going to go back to my components. my components tell me I'm negative 172 this way, and I'm negative 249 this way. So my resultant vector, the vector I'm trying to figure out, is this one. Okay, for my bearing, I want this angle here. The 55 that I just found is our reference angle. It is that. So for my bearing, in this case, this whole thing would be 270. I want that less. So I'm going to do 270 minus the 55.36, which gives me 214.64 degrees. That is my bearing that the plane is actually going, or the course over ground, if you will. Okay, so our next problem. 3 rugby players are pulling out the ball. Player 1 pulls with a force of 6 newtons. Player 2 pulls with a force of 4 newtons. The angle between them is 150. There is a third player, 3, who makes it so the ball does not move. Okay, if player 1 is placed on the positive x-axis, draw a vector diagram representing the situation. Okay, so I'm going to place player 1 on the positive x-axis. Okay, player 2 is at 6 newtons. Okay, player 2 is 150 degrees away. So I'm going to draw another vector here where this is 150. This is player 2 with a magnitude of 4 newtons. Our third player is going to be somewhere down here. Okay, so what we want to find are the magnitude and direction of these vectors. If player 1 is placed on the positive x-axis, what is the vector representing player 3 written in component form? So here, player 1 is just going to be 6 in the x direction. Player 2, the reference angle here is going to be 30, and it's going to be a negative positive. So negative 4 cosine 30i plus 4 sine 30. That gets me negative 3.464i and positive 2j. Okay, so if I add player 1 and player 2, we have 2.536 in the x direction and 2 in the y direction. So if that's what player 1 and player 2 are added up to be, player 3 needs to be the exact opposite of that. So player 3 is going to be negative 2.536i minus 2j, which matches my picture, which if this was in the positive x-axis, this is a negative negative. The force is going to be the magnitude of that. So we'll just do the square root of 2.536 squared plus 2 squared gives me 3.23 newtons. For these two, okay, we want to find the angle here and the angle here. I'm going to start by finding that angle. That angle is going to be the tangent inverse of 2 over 2.536. That is 38.26. So this is 38.26. To get to this player, I'm going to take that value and subtract from 180. Which is 141.74. To get the last one, this angle, I'm going to add the 30 and the 38. So those are our two angles. Okay, Okay, given a vector v with a magnitude of 2 inches in the direction north, 40 degrees west. So we've got north, east, south, and west. This convention, we start either north or south and then go east or west. So the 40 degrees is going to be measured from the y-axis. This is my 40 degrees. Okay, 2 inches. You don't necessarily need to draw this one to scale, but we have the tools, so why not? Okay, so this angle is 40 degrees. Okay, the reference angle is going to be this angle. Okay, the corresponding bearing. Okay, if we wanted to give it as a bearing. Bearing goes from due north going clockwise. So that angle would be 270 plus 50, which is 320. And then the components. The components, we're going to use the reference angle of 50 and the fact that this is negative, this is positive. So this one is going to be negative 2 cosine 30, which is negative 1.286. This will be positive 2 sine 30, not 30, sorry, 50. Okay, which is going to be 1.532 inches. Okay, so now we get into on the coordinate plane. So write the ordered pair representation of the vector AB. So the ordered pair, we're saying how far in the x and how far in the y we're going. For A, we start at 2 and go to negative 3. So that's going to be going back 5. And then if I go from 3 to 5, we're going up 2. The magnitude, that's what this notation is asking for. The magnitude of AB is just simply using the Pythagorean theorem. So you get the square root of 29, or you can do the decimal approximation. For this one, I'm starting at negative 4, going to negative 7, so that's going to be negative 3 in the x direction, and then 6 to negative 3 is negative 9 in the y direction. So we have 81 plus 9 is going to be the square root of 90. Find D so that AB and CD have the same ordered pair. So AB, just like in the previous problem, we're going from negative 2 to 3, so that's 5. And then we're going from 5 to 4, so that's negative 1. So D, I'm going to start at 1 and go right 5. So it's going to end at 6. For the y values, I'm going to start at negative 3 and go down 1. So that's going to be negative 4. This one, we're going from 4 to 1. So negative 3. Negative 2 to 3 is 5. So our point D, starting at 7, going back 3, is 4. Starting at negative 12 and going up 5 gets me to negative 7. All right, so we've got two vectors in ordered pair form. So for this one, we're going to have 2 times negative 2, 5, minus 3, 7, 3. So we'll distribute. So we're going to have negative 4, 10, minus 21, 9. And then you'll subtract the pieces. So negative 4 minus 21 is negative 25. 10 minus 9 is 1. Distribute again to get a 21 and 9. So we get 19 and 14. This notation is for the dot product. The dot product, we multiply the x's, multiply the y's, and add them. So this will be negative 2 times 7 plus 5 times 3, which ends up being 115 minus 14. For the next section, to determine if the vectors are parallel, perpendicular, or neither, we're going to use the dot product. So negative 3 times 2 plus 6 times 1. Okay, that's negative 6 plus 6, which is 0. If the dot product is 0, our vectors are perpendicular. Here, if I do 4 times negative 2 plus 10 times negative 5, we get negative 58. Okay, so not perpendicular. So what we're going to do is create a perpendicular vector by switching these and changing the sign of one of them. So I'm going to move the 5 in front there, and I'm going to take the dot product of those two. So we get that, which means they are parallel, because these two are perpendicular, these two are perpendicular, which means those two are parallel. Do the dot product, we get 12 and 12 is 24. Switch places and one sign, and then do the dot product. Which is going to be negative 18 plus 8, so negative 10. So this is going to be neither. So we're going to find K so that these two vectors are parallel and so they are perpendicular. So for them to be perpendicular, their dot product needs to be 0. So negative 4 times 3 plus K times negative 5 needs to equal 0. Minus 5k equals 0. So negative 5k equals 12. So k is going to be 12, negative 12 fifths. For them to be parallel, I'm going to create a perpendicular b, which is going to be positive 5, 3 if I switch the signs, and then do the dot product of these two. So negative 4 times 5 plus 3k equals 0. So that'll be 20 added over, so my k is going to be 20 thirds. All right, we have a point and a direction vector. So we're going to write the vector equation of a line, which is the points that were given plus t times the vector. So for this one, it's going to be 4, negative 3 plus t times negative 7, 5. The parametric equations for the line. The general equation is x equals x1 plus a1t, y equals y1 plus a2t. And then we just plug in that information. So 4 minus 7t, negative 3 plus 5t. Finally, the slope-intercept form. We have our point, which is 4, negative 3. The slope is going to be the change in y over the change in x, which is going to be 5 over negative 7, or negative 5/7. So if I use the point slope form, we're going to have y plus 3 equals negative 5/7 x minus 4. So this will be plus 20/7. Okay, this would be 21/7. So if I have 20/7 minus 21/7, we get minus 1/7. Okay, to write the parametric equations of the line, I'm going to first put this in slope-intercept form. So y is going to be 3/8 x minus 12/8, which 4 goes into both of these, so that's going to be, minus 3/2. So as long as I have a point and a slope, we can write the parametrics. My point, I'm just going to do the y-intercept. The slope, okay, is 3/8. That's going to equal my delta y over my delta x. So x is going to equal 0 plus my change in x, t. Sorry, that should be t. My y is going to be negative 3/2 plus my change in y times t. Okay, next we're going the other direction. So from this, I know negative 2/8 is on my line, and I know my slope is going to be negative 2/3. So then I can plug that into point slope. Okay, so 8 would be 24/3. So if I add 24 to negative, sorry, this should have been a plus here, because that's minus, which makes that a minus. So 24, if I add that over, we get 20/3 for our slope-intercept form. So in our last section here, we are going to write the parametric equations take the parametric equations and turn them into rectangular form. We're going to graph it and then indicate the direction of motion. Okay. This is just the structure for a line. So I know the point on the line is -5, -4. My slope is going to be 3/1. Okay, so plug that into the point slope form. Okay, so that's what we are graphing here. Go to 11. Okay, so my line crosses at 11 and then has a slope of 3. Let's do a couple points here. So that's my line. Okay, just have a couple accurate points. What I would do to find direction on this is just plug in values of t and see the direction. So I really only need 2. So I'm going to plug in 0, which would give me the point -5, -4. And then if I plug in 1, we get -4, and 3 minus 4 is -1. So we're going from -5, -4, which is somewhere down here. Then we're going -4, 1. So my direction is going to be this direction. Okay, so for this one, I'm going to solve each of these equations for t and set them equal. So x plus 1 equals t squared. So t is going to equal plus or minus the square root of x plus 1. In this one, y minus 1 equals 2t. So 1/2 y minus 1/2 equals t. Then set them equal. and solve for t, or solve for y. So 1/2 y equals 1/2 plus or minus root x plus 1. And then y, then if I multiply by 2, is going to be 2 plus or minus, or 1 plus or minus 2 root x plus 1. Okay, so we can graph this parametrically. We can make a table of values, or you can use your calculator. So I'm going to make a table of values using my original equations here. If we plug in -2, that's going to be 4 minus 1, which is 3. If I plug -2 in here, we get -4 plus 1, which is -3, and so on. So we get 0, -1 here. If I plug in 0, we get -1, 1. If we plug in 1, we get 0 and 3. If we plug in 2, we get 2 squared minus 1 is 3, and 4 plus 1 is 5. So now I'm just going to graph the points. So 3, -3, followed by 0, -1, followed by -1, 1, followed by 0, 3. So I'm graphing these points going like this, so my direction is going to be that way. Okay, for this one, we're going to use the fact that sine squared t plus cosine squared t equals 1. So in each of these equations, I'm going to solve for cosine squared or sine squared. So x over 2 equals cosine of t. So cosine squared t is x squared over 4. Y over 2 sine equals sine of t. So if I square that, we get that. And then I'm just going to replace those in here. So we have y squared over 4 plus x squared over 4 equals 1. And then I can multiply both sides of this by 4 to get x squared plus y squared equals 4. To graph it, that's just a circle centered at the origin with a radius of 2. Okay, to indicate the direction, I can plug in specific values. So I'm going to plug in 0 and pi over 2. If I plug in 0, cosine of 0 is 1, so I get 2. Sine of 0 is 0, so that's the first point. If I plug in pi over 2, my x is going to be 0 and my y is going to be 2. So this one goes this direction. So that is your Unit 8 test review. Good luck.